Hey guys, today I'm going to be talking about the new controller and how the PAS modes 1, 2, 3, 4, 5 and throttle test out as far as the speed of the XP. What I will be doing today is I'll be going through each of the modes, the 5 modes, and also the throttle, and I will be testing their speeds at 100% battery level, 75% battery level, 50% battery level, and 25% battery level. What I will try to gather as far as my data is an average speed on level surface with no wind for each of these modes and full throttle. Since this is not a perfect world, there is a slight wind during the collection of this data. It's very slight. I don't think it's going to have much to do with the result. And the course that I use has slight grades to it. I did find out that certain stretches in this course are leveler than others. Some are fairly level. And after doing a number of tests and collecting data, I realized where these level and flat surfaces were. And this is where I tried to draw my data information from, because the slightest incline or decline will greatly affect both your speed and the amount of current you're using in that particular PAS mode. So it is very critical for accuracy for it to be level with no wind, no headwind, no tailwind, no downhill, no uphill. So I tried to filter those out as much as possible in the course. The course that I rode is a fairly flat course, and I think my data serves itself well for me. Now, it's one thing you need to realize, that this is with the new controller. The old controller, which is the original controller, and this particular bike had the original controller. Their PAS modes 1, 2, and 3 were programmed differently from the new controller. The old controller's PAS modes 1, 2, and 3 were approximately 3 miles per hour faster than the new reprogrammed controller. Now, on my bike, I damaged the controller about 8 months ago, or 9 months ago, and I had to purchase another controller from Lectric. Well, the controller that they sent me had been reprogrammed so that all my PAS modes and my throttle are the same as the newer controllers that they put on the present model. I know some people are going to wonder, well, is the new version 2 of the Lectric XP, is that controller different? Well, I have no knowledge of that at this time. Those are new bikes. I'm going to assume that they're probably programmed the same as the previous model was, the newer controller on the previous model, but I don't really know. So this holds true for just about all your step-throughs. Any bike that was built probably after about July of last year was when they, I may not be exactly accurate on my time period, but I think it was around July of last year that they changed the controllers out. It was about the same time that the step-through models came out that the controllers were reprogrammed. But this one does have the new settings. My wife has a step-through, and out on our rides, now I notice that when I'm in PAS modes, that if both bikes are fully charged or charged at the same level, that we are compatible with each other. We run about the same speed. Prior to that, when I had the older controller and she had her step-through, there was a little bit of a problem because my bike wanted to run faster in modes 1, 2, and 3 settings than hers did, so it's hard for us to sync in a ride. But I don't have that problem anymore. So with that said, I'm going to go ahead and I'm going to do a static check. I've got it up on my stand here. I'm going to change the location of the camera and everything and do a static check so I can compare this with the data that I collected about 11 months ago, and I did a video back then with the old controllers. So I've got previous data from the old controller that I can compare with the new controller, and one of those are static runs. So I'm going to go ahead and do a static run to see what speeds I reach in my different PAS modes and full throttle. This is a quick look at the data that I obtained for this video. Before I will go into detail of this data, I'll show you briefly how this information was collected. Okay, I'm going to start out now. I've got my battery, my voltage level down to about 50.3, which is right at 75%. I'm going to go to first gear and cut on my wind gauge. And now I'm at my 75% ride. I did my 100% yesterday, and this will be my 75% right now. We're going to start out PAS in 1. Okay, this is 1, which I'm pulling very, very little amperage. Okay, now I'm going to go to 2. gear 1. Like maybe 0.3. This is what to look for when on level road surface, wind speed to match bike speed. I don't know, wind's about light and variable, pretty flat. Go to 3. Yeah, I'm going to take it on up to 4. Get up to 5. Drop back to 1. Throttle on it. Here and start over again. Second run in the opposite direction. This is the 2.9 mile course that I rode to collect the data for this video. Note that it is a relatively flat course. The 2 days that I rode this course to collect the data, wind was light and variable. I will now show how I obtained data for a static run on my work stand with no bike loading. Okay, I'm going to start out in PAS 1. I've got fully charged battery, so we'll see what speed this will develop with no loading on it at all. I'm going to turn the crank just enough. I've got it in first gear, so I won't ever catch up with the motor when I turn the crank real slowly, just enough to engage the motor, and we'll see what speed we get up to. And I'm going to do this through each of my modes, so it will be no human power to interfere with these results. Let me try to explain a little bit on my theory as how this controller works. This controller really works off of, in each of the PAS modes and the throttle, it dictates a certain amount of current to go to your motor. Now this current is also in conjunction with that, it has a target speed that it tries to reach within this current, in the range of that current. Now, as you know, as most people have noticed, that the more loading on the bike, the current draw goes up and the voltage level drops. So, well, this also happens as your battery starts losing its power and the battery drops down from 54.6 down to less than 42 volts. The current level will try to maintain the same current level, and so consequently the speed will drop. So this is the target speed evidently this controller has for PAS 1. I'm going to go now to PAS 2. This is PAS 2. Pedal just enough to get the motor engaged. And as you see here, due to the friction of the wheel turning and everything at a higher speed, it's requiring a little draw current. So you've got about 1 amp of current that it's drawing. If you noticed in 1, it didn't indicate it was drawing any current. Well, it was, it just wasn't registering any. So now we're in PAS 2. I'm going to move it up to PAS 3. Okay, now we're in PAS 3. Now we'll go to PAS 4. And now we'll go to 5. Now I'll go to full throttle. Put it in walk mode. I will now discuss the data that I collected for this video. I did a video a year ago using the old XP controller. Shortly after that video, Lectric reprogrammed the XP's controller. This is the data from last year's video. I will be making some comparisons between this video from the older XP controller and the data I collected for this video from the new reprogrammed XP controller. This is new controller data. In this data, the controller was set up for class 3 and does not apply for the controller when set up for class 2. I made 4 sets of runs at varying voltage levels. 100% at 54.6 volts, 75% at 50.3 volts, 50% at 47.4 volts, and 25% at 45.8 volts. In each set, I did 3 runs. Each run was starting out in PAS mode 1 and continuing through all modes to PAS mode 5, then finishing with a full throttle run. In each of these modes, I recorded the speed and current. I also made minor adjustments by omitting questionable data. With this data, I determined an average speed and current for each mode at each battery level. It is to be noted the weight of the rider affects speed and currents. The lighter the rider, the speed would increase and the current level would decrease. In theory, without interference, the current amperage, as programmed by the controller, should be constant at all battery voltage levels within each PAS mode. The speed loss should be due to the drop in voltage as the battery is being discharged. Variables such as headwinds, tailwinds, and variations in grades from zero wind to perfectly level road surfaces will affect current loading data readings. Examples: going uphill, battery voltage will fall and current amperage will increase, and conversely, going downhill, battery voltage will rise and the current amperage will decrease. It is very hard to find a completely level road surface, and the slightest slope will affect the current readings. After many runs on this road course, I found several sections that were very close to level and found that the current level reading at any voltage level, 100% through 25%, would be the same for that particular PAS mode. As theorized above, I have determined that the controller is governing the current supplied to the motor at a particular current level for each PAS mode. The controller also has a target speed for each PAS mode and full throttle, which decreases as the voltage level of the battery decreases. The speed of the XP in each of the PAS modes and full throttle is a derivative of the e-bike's loading, wind, weight, and surface level of the road, and the battery voltage level. The current level amps for any PAS mode and full throttle without outside loading interference will remain the same. As the battery voltage drops, the speed of the XP will decrease. Note, all XPs are not the same. I have an older standard XP and my wife has a newer step-through model. I damaged my original controller and replaced it with a newer controller, which was reprogrammed to the newer PAS mode standards, which works fine in that my XP is now in sync with the PAS modes of my wife's XP. Even though now, with both batteries fully charged at the same voltage level, we run at the same speed when in the same PAS mode, but our speedometer readings differ. Her speedometer reads a little over 1 mile per hour faster than mine. I tried to change the controller speedometer settings, but they are locked. No big deal since my speedometer readings are close to the GPS app readings, but it does mean that my wife's XP speedometer readings are a little fast. This chart shows the speed comparison between the new reprogrammed controller and the original older controller. The data for the older controller was taken from data I collected for the video I did last year on this subject. Since the comparing data is from 2 different data sets, a 0.3 mile per hour variance is not surprising between the 2 controllers. I believe that PAS 4, 5, and full throttle were not reprogrammed and should be the same between the new controller and the older controller. This chart shows the speed results without any load from the static run on the work stand that I showed previously in this video. I believe these are the target speeds that the controller is programmed for each of the PAS modes and full throttle. In each mode, once the motor is subjected to a load, the voltage level will drop and the current flow will rise, causing the speed of the bike to slow down accordingly to the increase in amount of the load. PAS 5 differs from the other modes in that the controller has a maximum speed limit of 28 miles per hour, and once this speed is reached, the motor will turn off. This graph shows speeds with loads and without loads and current levels in each PAS mode and full throttle. Well guys, this concludes my video for today. I hope that you've enjoyed it. I hope you've got a little more knowledge on how your controller works and your speed related to your controller. So until next time, y'all have a nice day. Thank you for watching.